Now, so far we have talked about the large and small values, and for large values we do this, for small values we do that. Well, but how small is small? Okay, so at what point are we going to say, oh, this probability is small? The value I gave you in the example of 0.0007 is fairly low. Okay, but is even that one, is it low enough? So how are we going to check? So in other words, how low do we want to get with that p-value before we can actually say, yes, that's small enough, we're going to conclude that the alternative hypothesis seems more convincing. Okay, the threshold value that we're going to use, that we're going to pick, is called the significance level, and you're often going to see it denoted by the Greek letter alpha. Okay, now that just gives a name, but how much is it? Well, the value of this significance level is picked arbitrarily. You basically can pick whatever you want. It's an arbitrary choice. Tradition suggests and dictates that some values are more commonly used than others, but any value that is used is always arbitrary. Now, the common ones that are used are 0.05 or 5% or 1 in 20, and 0.01 or 1% or 1 in 100. Occasionally you're going to see other significance levels being used, but those are the ones that you're going to see more commonly used, especially the 0.05. The 0.05 in fact is so commonly used that some people believe that there is some kind of scientific meaning, scientific relevance, scientific significance to it, but in fact there isn't. It's just a number. There is actually an interesting story about where that number comes from, and was just a wild guess made by a statistician that he thought, that was a reasonably good number in a certain situation, and then from there on everybody kept using it. Now, if p is less than alpha, so if the p-value is actually lower than whatever significance level we have chosen, then people say that the data are statistically significant. On the other hand, if p is greater than alpha, we say that the data are statistically insignificant. Okay? Now, these two expressions, and particularly the word significant, so these two things here, are the cause of immeasurable and very commonly widespread misconceptions and misuses. Notice that what I'm saying here is not that the conclusions of the study are significant. I'm not saying that what we found out was very important for humanity, or that it was even very convincing, or something that should lead us to change the way we do things. All we're saying is that the data we collected generated a p-value less than the significance level. Okay, so this has nothing to do with practical significance of the research. Okay? And this is again a confusion that unfortunately gets done very often. I hope you don't do it, because it's a very important and quite often dangerous kind of confusions to be done. So let's see how that works out in our good old example, and then we'll explore this some more in class. So let's go back to our example. So for the jumping jack question, let's assume first of all that we, like everybody else, pick the 5% significance level. Okay. Now remember, the p-value that we computed was 0.0007, which is probably even closer to 0 than what I'm showing there, but just to show you, it's much lower than the 5%, is practically 0, right? Now remember, you want to be careful with probabilities, and even small numbers need our respect. So in this case, we can say that the data are significant. Our p-value is significant. One way that people will also express that is by saying that we can reject the null. We're going to reject the null. We're going to conclude that the null is not true. Okay? But again, we need to be careful. We can't keep going, jumping up and down and say, yeah, we got a great result. We can now know from now on and for all eternity that this is true, and so on. You need to slow down. The difference may still be due to chance, remember? Yeah, you may not be happy about that, but even such a strong, what seems like such strong evidence may still be due to chance. Not only that, but even if it's not due to chance, and even if, in fact, we can conclude that in the population, we can be quite confident that in the population, those two values are not the same, but the difference could be practically irrelevant. Okay? My favorite example is just to say, well, we could do a study that shows that one kind of treatment cures the cold, the common cold, in 7 days, while another one cures it in 6 days, 59 hours. Sure, 59 hours. 6 days, 23 hours and 59 minutes, and I could have statistically significant evidence to back that up. Okay, but look at the difference. 1 minute. Does it really make any practical difference? Okay, so don't be hypnotized by the jargon of significance, and keep in mind that this is only referring to the relationship between the observed p-value and the chosen significance level. And keep in mind that since the significance level is arbitrary, sometimes it can happen that the same data can be called significant with one choice of significance level and not significant with another one. And this is something we're going to see later on, and we're going to analyze through examples. So just keep working with this thing, use your articles to practice, and keep generating questions. Keep not getting frustrated by the possible confusion, and keep working at eliminating this confusion eventually.